Good morning, students. Write your name, seat number in the chat box. So till some students are not joined, we will start. Within 2 minutes, we will discuss about the post-wall dilution law again. Yesterday, we completed this post-wall dilution law again. Also, we have take the revision of acids-base theories, Arrhenius theory, Lowry-Bronsted theory, then Lewis theory. It is also called as Lewis theory. Then what is meant by conjugate acid-base pair? What is meant by strong acid, strong base? Then also we discussed this Ostwald dilution law for weak acid and weak base. So this Ostwald dilution law is nothing but it is the relationship between degree of dissociation alpha and dissociation constant, that is Kb or Ka. Ka is the dissociation constant of weak acid and Kb is the dissociation constant of weak base. So actually only we have to remember this table. With this table we can derive the equation. Initially see, if this Ha is considered as a weak acid, it will be dissociated as H plus and A minus in water. So according to the law of mass action, this equation is written: K is equal to the molar concentration of H plus ion into the molar concentration of A minus ion and divided by the molar concentration of Ha. This is according to the law of mass action. In 11th standard, we studied what is meant by this law of mass action. So initially, what 1 mole of acid is initially present and the volume is VDM cube. Initially means before starting the dissociation, 1 mole of acid is present, and at equilibrium what will happen? The fraction of Ha will be dissociated and it is called as alpha. So alpha is the degree of dissociation, means fraction of acid dissociated. So at equilibrium what will happen? The alpha, it will be means 1 minus alpha, it will be the amount of acid. Actually 1 mole of acid is present and alpha is dissociated. At equilibrium the concentration of H plus will be alpha, means it will be dissociated, and the concentration the amount of H plus will be alpha because it is dissociated. Fraction of alpha, H plus will be dissociated and fraction of A minus will be dissociated. So undissociated will be 1 minus alpha, because 1 mole of acid is present at equilibrium, and at 1 mole of acid is present initially without means at initially 1 mole of acid is present, and equilibrium what will happen? Alpha will be dissociated. So the amount present at equilibrium, amount of Ha present at equilibrium will be 1 minus alpha. Remember, yesterday 2 students called me, sir, we didn't understand this 1 minus alpha. That's why I again explain what is this 1 minus alpha. And this is a concentration. Initially the concentration before dissociation, it is V. Concentration before dissociation is V. So at equilibrium the concentration will be alpha upon V for H plus and A minus. If you understand this table, then we can derive easily. So if you understand the equation of weak acid, then this equation of weak base is exactly same. See, so the alpha is equal to under root Kb into V, means this alpha is directly proportional to the square root of volume of the solution. and this alpha is equal to square root of inversely proportional to the square root of the concentration of the solution. So with this expression, we have to solve the numericals, remember. So the numericals, today we will start the numericals. I think you are seated with your notebook and pen. So what type of numericals will be asked? See, we will discuss this numerical number 1. The weak monobasic acid is 0.05% dissociate. So here clearly we can understand the percentage dissociation is given because the symbol percentage is there. 0.05% dissociated in 0.02 molar solution, means the concentration is also given and the percentage dissociation is also given. And what is asked? Calculate the dissociation constant of the acid, means Ka we have to calculate here. Ka we have to calculate. So you having the formula of K and C, because you know according to the Ostwald dilution law there is a relation between dissociation constant and alpha. So the dissociation constant of the acid, weak acid, is given by Ka is equal to alpha square C. See, this equation we already know, Ka is equal to alpha square C. Here alpha is percent dissociation, remember, because in percentage it is given. So alpha is equal to percent dissociation divided by 100. So this 0.05 divided by 100 is equal to 5 into 10 raised to minus 4. First we have to calculate this alpha because in percentage it is given. We have to solve divided by 100, 5 into 10 raised to minus 4. Then the concentration is given C 0.02 molar. So it will be converted into 2 into 10 raised to minus 2 molar. So put the values of this alpha and C. So alpha is already calculated, 5 into 10 raised to minus 4 square into 2 into 10 raised to minus 2. So if you understand these values, then mathematically we can solve it. So the final answer we will get here 5 into 10 raised to minus 9. This is the final answer. This is a Ka, that is the dissociation constant of the acid. Then second numerical is, see the second numerical, the dissociation constant of NH4OH, it is a base, it is given. Now it is a weak base. NH4OH is a weak base. Its dissociation constant is given 1.8 into 10 raised to minus 5. Means the value of Kb is given here. And what is asked? Calculate its degree of dissociation. Kb, alpha, it is asked degree of dissociation, means alpha we have to calculate in 0.01 molar solution, means the concentration is also given. So we already know this relation. The degree of dissociation alpha is equal to Kb into C. This is according to the Ostwald dilution law. Now what is given? We have to calculate this alpha value of this Kb is given and C is given. Simply we have to put these values. Before putting the values, we have to write the given values. So Kb is given 10 raised to minus 5 and C is given concentration 0.05 molar. That can be converted into 1 into 10 raised to minus 2 molar. So we have to put these values of Kb and the C in this equation. So alpha is equal to 1.8 into 10 raised to minus 5 under root divided by 1 into 10 raised to minus 2. So by doing the division, we will get 1.8 into 10 raised to minus 3. That is 18 into 10 raised to minus 4. By shifting the decimals, we can convert this 18 into 10 raised to minus 4. So by taking the square root of this 18 into 10 raised to minus 4, we will get this value 4.242 into 10 raised to minus 2. Or you can convert into this, we can shift the decimal. So this is also correct and this is also correct. So this is a 3 marks numerical, remember. Sorry, this is 2 marks numerical. This is also 2 marks numerical. Then we will discuss this next numerical. I will discuss this numerical and I will start the next point. So read the numerical carefully, because in this chapter 1 numerical will be asked for you. Remember, numericals will be asked from solid state, chapter number 1. Numerical will be asked from chapter number 2, that is solutions. Numerical will be asked from this chapter, Ionic Equilibria. Numericals will be asked from chapter number 4, that is chemical thermodynamics. And one chapter is remaining, that is electrochemistry. So this chapter, physical chemistry chapters having the numericals. First, read the numerical carefully. A weak monobasic acid is 12% dissociated. So 12% dissociated means it is a percentage dissociation. Alpha is given. Alpha is given in percentage. You know how to convert divided by 100. We have to convert it. Then 0.05 molar means the concentration C is given. And what is asked? What is the percent dissociation in 0.15 molar? Means percentage dissociation it is given in 0.05 molar solution it is given, and we have to calculate percentage dissociation in 0.15 molar solution. Means alpha 1 and alpha 2. If alpha 1 and alpha 2 are the values of degrees of dissociation of two different concentrations at C1 and C2. So C1 and C2 it is given here. If it is considered as C1, it will be considered as C2. So K is equal to alpha 1 square C1 is equal to alpha 2 square C2. Therefore, alpha 1 square C1 is equal to alpha 2 square C2. So alpha 1 it is given 12% means we have to do this 12 divided by 100. Then C1 its concentration is given 0.05 molar. Then the C2 is also given concentration. C2 is 0.15 molar is given, and we have to calculate this alpha 2. So we have to put these values in this equation. We have to put these values in this equation. So alpha 2 square is equal to alpha 1 square C1 divided by C2. So by substituting these values, we can get 0.12 square. What is this? 0.12, remember? See, 0.12 square, this is alpha 1 square into its concentration, alpha 2 square, and its concentration is given. So by putting these values and solving this equation, we will get this 0.0048. Hence alpha 2 is equal to 0.0693 percentage. This is a alpha 2, means we have to calculate this alpha 2 value, percent dissociation value in 0.15 molar solution. This is a 3 marks numerical, remember. This is not asked for 2 marks because we have to think about this alpha 1 and alpha 2. So for writing this formula, 1 mark is reserved. This Ka is equal to alpha 1 square C1 and is equal to alpha 2 square C2. For writing this formula, 1 mark is reserved. So if you write this formula, you will get 1 mark. Then by substituting these values, and we have to find the answers. It is given 2 marks. It will be given 1 marks for putting the values and 1 mark for calculation. So it is a 3 marks numerical. So remaining numericals we can calculate at your home because these are all solved numericals. If you found any problem, you can call me. So we will start the next part, that is ionization of water. So actually the pure water, when it is dissolved in water, means pure water ionizes, it is in very small extent. So the ionization equilibrium of water is given. So water is dissolved in water here. H2O liquid, it is pure water dissolved in liquid. So its dissociation, it is given here. It is not completely dissociated. It will be dissociated very small extent. So it will get H3O plus aqueous and OH minus aqueous. These ions are formed. This is a cation and this is anion will be formed. Then equilibrium constant, you know how to calculate this equilibrium constant according to the law of mass action. So K is equal to the molar concentration of H3O plus into the molar concentration of OH minus divided by here H2 and H2O. So it will be taken as H2O square. This step equation 3.12 is according to the law of mass action, remember. So what is the law of mass action? It is the product of molar concentration of the product divided by the molar concentration of the reactant. It is law of mass action. It is already discussed in Ka and Kb expression also. So this K is equal to H3O plus multiplied by OH minus divided by H2O square. So this H2O square, when it is multiplied to this left hand side, it will be K into H2O square is equal to H3O plus and OH minus. Only in this step we have multiplied this H2O square, it is taken into this left hand side. So the majority of H2O molecules are undissociated. In case of ionization of water, majority means large number of H2O molecules are remains undissociated. Only small amount of water it will be dissociated. So its concentration is taken as constant, remember. Which concentration? Concentration of this H2O, it is taken as constant because only small amount of water molecules will be undissociated. So again new constant is written K dash. This is K dash, it is a concentration of H2O square because majority of water molecules are undissociated, so it is taken as constant. So concentration of H2O square, it is denoted as K dash. So this expression will be, equation number 3.13 will be K into K dash, where K dash is what? This is a concentration of H2O square. So K into K dash is equal to, this remains as it is, molar concentration of H3O plus and molar concentration of OH minus. So this K into K dash, it is called as Kw, and what is this Kw? This is called as ionic product of water. So this expression can be asked for the board examination. Derive the expression for ionic product of water. So we have to write these steps. It will be asked for 2 marks. So Kw is nothing but K into K dash, where K dash is the concentration of H2O. Remember, it is taken as constant. So the ionic product of water, by this equation we can write the definition. the product of molar concentration of hydronium ions and hydroxyl ions at a given temperature, it is called as ionic product of water. So this definition is given. This definition is prepared by using this equation. We can also write the definition. Kw, it is ionic product of water, is the product of hydronium. This H3O plus is called as hydronium ions, and this OH minus it is called as hydroxyl ions. So it is nothing but the product of hydronium ions and OH minus ion at a given temperature. It is called as ionic product of water. In pure water, remember one thing, in pure water, this concentration of H3O plus and the concentration of OH minus is exactly same. Means these two concentrations are exactly same, and it is given here. Thus at 298 Kelvin, this concentration it is found in pure water, that is concentration of H3O plus and the concentration of OH minus is exactly same. It is given 1.0 into 10 raised to minus 7 moles per liter. This is the molar concentration of H3O plus and OH minus. So by putting this value 1.0 into 10 raised to minus 7 in this equation, Kw is equal to 1.0 into 10 raised to minus 7. This is the concentration of H3O plus, and 1.0 into 10 raised to minus 7. This is the concentration of OH minus. As we know, in pure water, both the concentrations are same. So by doing the multiplication, we will get 1.0 into 10 raised to minus 14. So this Kw having the values, ionic product of water at 298 Kelvin, the value is 1.0 into 10 raised to minus 14. Remember this value because this will be required for solving the numericals. Then depending upon this Kw, there is a relation between pH, pOH. So we will discuss what is mean by pH. From the, I think, 7th standard, we are already familiar with this word pH. pH, it is nothing but the concentration of negative. It is defined as, chemically it is defined as the negative logarithm to the base 10 of the concentration of H plus ions. So pH, it is the potence of hydrogen. The definition it is given. Chemically we have to write the definition. The name of the scientist Sorensen in 1909 defined the pH. So this introduction part is not given, but remember the name of the scientist who discovered this pH and pOH. The name of the scientist is Sorensen. So pH is nothing but the concentration of H plus ions, and the pOH means the concentration of OH minus ions. But chemically we have to write this definition. It is the negative log of concentration of H plus ions, and pOH is negative log of concentration of OH minus ions. It is mathematically it is shown pH is equal to minus log to the base 10 H plus ion concentration, and pOH is equal to minus log to the base 10 OH minus concentration. These definitions can be asked for the examination for 1 mark. What is mean by pH and what is mean by pOH for 1 mark. Then this relation between pOH and pH and pOH, this is asked for 2 marks. Make a very IMP there in your textbook or notes also. This is asked for 2 marks. So for this derivation, we required the ionic product of water. So you know what is the ionic product of water, Kw. It is the ionic product of water. You know it is the concentration of H3O plus. Just we discussed, we derived this equation. Kw is a concentration, molar concentration of H3O plus and molar concentration of OH minus, and you know its value is 1 into 10 raised to minus 14 at 298 Kelvin. This equation is already derived. So from this equation we will start H3O plus OH minus into 1.0 into 10 raised to minus 14. This already you know. This is taken from the ionic product of water. So by taking logarithm of the equation from logarithm of both the sides, we will write log to the base 10 H3O plus because multiplication is there, log 10 the OH minus ions is equal to minus 14 because the log of 1.0 into 10 raised to minus 14 is minus. By multiply this equation with minus 1, so it will be minus log 10 H3O plus, it will be minus log 10 OH minus is equal to plus 14. So you know minus log 10 to the H3O plus ions and minus log 10 to the OH. H3O plus, it is nothing but H plus ion concentration. So we will write minus log 10 log to the base 10 H3O plus, it is pH, plus minus log to the base 10 OH minus is POH. So this is pH, this is POH is equal to 14. This is a simple derivation. It will be asked for 2 marks, remember. For the board examination, make a very important for this equation. If you remember this ionic product of water, only we have to remember this equation: H3O plus, concentration of H3O plus into molar concentration of OH minus is equal to 1.0 into 10 raised to minus 14. So in the first step, we have to take the logs. In the second step, we have to multiply with minus 1 and it will be derived. So we will get easily 2 marks. And also the 1 mark or 2 marks numericals are there on this. So depending upon the concentration of H plus ions and concentration of OH minus, there are 3 types of solutions. First one is a neutral solution, which is having the pH is 7, acidic solution, which is having the pH less than 7, and basic solution, which is having the pH more than 7. So remember this neutral solution, acidic solution, basic solution. This is a non-evaluative part for this year, remember. No any question will be asked on this part, but for the CET, for the JE purpose, you must know the acidic solution, basic solution, and neutral solution. You know the pH of water is always 7. Here is one pH scale is given. So the 0 pH, it is very strong acid, which is used in battery. That is a strong HCl, hydrofluoric acid. Hydrochloric acid, hydrofluoric acid, which is used in batteries, which is having the pH is 0. This acid created in stomach, this is having the pH is 1. Then this is lemon juice, which is citric acid, which is having the pH is 2. Then pH 3, it is grapefruit juice, orange juice, and soda contains the pH is 3. Then tomato juice, acid rain, which is having the pH is 4. Coffee. So coffee is not good for health because it creates acidity, and if you take the pH of coffee, it is denoted with 5 pH. Then milk is having the pH is 6, water is 7, and then pH will be means this is acidic solutions. This is strong acidic, and this is neutral, and the basicity will be increased from pH 8 to 14. So blood having the pH is 8, then eggs, the liquid which is present in eggs, if you take the pH, it will be 9. Then tablets which for antacids, which is having the pH is 10. Then ammonia solution having the pH is 11. Then soap 12, bleach 13, and drain cleaners. Drain cleaners means these are the liquid which are used for drain cleanings. Many liquids are available in the market, and that liquid is having the pH is highest pH, which is 14. So this part is actually non-evaluative, so I am not explaining in detail, but for the knowledge purpose, this is required because this practical is also included in your syllabus. we have to determine the pH of different substances. We have to determine the pH of different. In 11th standard also we perform this experiment. In 12th standard also one experiment is there regarding the pH. So we have to solve these problems. This part is a non-evaluative, but the problems will be asked for the exams, remember. Only the same problems will not be asked, they will change the values. So remember, whatever the problems which are solved in your textbook, same problems it will be not asked, but they can change the values and they can ask the problem. So we will solve this one problem. Calculate pH and pOH of 0.01 molar HCl solution. It is given here. So HCl solution, you know, it is a very, very strong acid. It will be dissociated completely. So this is a dissociation it given. When HCl is dissolved in water, it will dissociated as H3O plus and Cl minus. Hence, the concentration of H3O plus ion, that is the concentration of H plus ions is equal to hence the concentration of H3O plus ions is equal to C because C is the molar concentration is given here 0.01 molar. We can rearrange into this 1 into 10 to minus 2 molar. So putting, you know, this molar concentration is known. So pH is equal to, you know, this formula of pH. pH is equal to negative log to the base 10 H3O plus ion. So you know, this concentration is given now. So we have to take the log minus log 10 to the base 10 of this concentration value we have to put in this equation. It is 2. So pH is 2, and we have to also calculate the pOH values. So first we have to calculate the pH, and the pH will be calculated by using this value 0.01 molar. Concentration of H plus ion is given. So we have to calculate first pH. pH is 2, and you know this relation pH plus pOH is equal to 14. So if you know the value of pH, then we can calculate the value of pOH. It is 14 minus 2, it will be 12. So this is again 2 marks numerical. It will be asked on relation between pH and pOH, remember. If you know this formula, pH is equal to negative log to the base 10 of H plus ion concentration, and pOH is equal to minus log to the base 10 OH minus ion concentration. So by remembering this 3 equations, pH, pOH, and pH plus pOH is equal to 14, by knowing these 3 equations, we can write the definitions also. We can write the we can solve the problems also. So another one example is given here. The pH of solution is 3.12. pH is given. Calculate the concentration of H3O plus ion. Means we have to calculate of H3O plus ions. What is pH is given? You know this formula. According to this formula, pH is equal to minus log 10 H3O plus ion concentration. So we have to put these values in this equation. Log 10 means this negative sign, it is shifted to the right hand side. Log 10 H0 plus is equal to minus pH. So minus the this is for your understanding purpose. It is separated minus 3 minus 0.12 plus 1 minus 1. We can solve according to your ideas. Simplification it is given in these steps, but if by putting these values also we can calculate. So in detail, steps are given, how to calculate logs and how to calculate anti-logs, how to solve this by using log table. It is given here. So we can solve at your home this problem. We can solve at your home. So another two problems are given here. This problem is again weak monobasic acid is 0.04% dissociated, means it is a percentage alpha degree of dissociation. It is given in a 0.25 molar solution. What is the pH of the solution? It is given here. So first we have to write the equation Ha plus H2O. Ha plus H2O, then H3O plus plus A minus is A minus sign is remaining here. I will make a correction. You have to remember H3O plus and A minus. Actually, A minus should be there. So percentage dissociation, you know, alpha into 100. So alpha is equal to percent dissociation divided by 100. So we have to calculate first this value, because 0.04 percentage means 0.04 divided by 100. We have to calculate this value first. So H3O plus is equal to alpha into C. The value of H3O plus is also given 0. Weak monobasic acid. Yes, C is given here. Alpha into C, the value of alpha, it is calculated 4 into 10 raised to minus 4. It is written here. And this is a 0.025. This is a concentration. It is also given value. So alpha is given. Alpha you already calculated by using this formula. So alpha into C, if you multiply this alpha into C, we will get this value 10 raised to minus 5. This is the value of H3O plus. And by putting this value in the pH equation, pH is equal to minus log 10 H3O plus. So this 10 raised to minus 5 we have to put in this equation, and we can calculate the pH. So for calculating the pH, you must know the value of H plus ion. So value of H plus ion, it is calculated by using alpha into C. So this is again 3 marks numerical. Means for 3 marks numerical, we have to remember the formula also, we have to write the expression also, we have to put the values, and we have to calculate the answer. So this is the 3 marks numerical, and 2 marks numerical will be only we have to put the values and calculate. It is for 2 marks. This is a 3 marks numerical, because in this numerical we have to write this equation also. We have to remember this formula also, and we have to put the values and do the mathematical steps and calculate the answer. So this is as for 3 marks. So pH is equal to minus log 10. If you know this value 10 raised to minus 4, then remaining calculations you can do.